Good day. My name is Jonathan David D. De La Cruz. I am from the Technological University of the Philippines, Sagig campus. I will be presenting today a research on measuring understanding of electron distribution of atoms among pre-service and in-service physical science teachers using representational tasks. This study was conducted together with Ms. Arrianne Cortez and Professor Vic Marie Camacho. Our study is rooted on constructivist approach, constructing knowledge and understanding concepts. This allows the learners to construct their own understanding on a certain topic using a visual language. Constructivism and it's also hands-on inquiry-based on instruction to promote children's conceptual knowledge by building their own understanding based on their experiences. So they will be using science illustrations. So science illustrations is already being used by different fields of science like biology through illustrating other parts of the body. But for this case, we will be translating it to chemistry and physics, to physical sciences using atoms. Okay? And this would actually identify central scientific concept on understanding that topic. This could also help the learners hone their skills in presenting data using images. Representational task, according to Lansangan in 2018, allows the learners to organize and reorganize their thoughts in a picture of their idea. This is essential in measuring the extent of understanding in the disciplinal content as alternative to traditional methods, since representational task is an authentic assessment. This was actually developed by Kozma in 2003, and he proposed 5 levels of understanding, which we will be using in assessing the learners. This is also an outcomes-based activity since it is an authentic activity, allowing the learners to establish their own understanding. And this could actually help in identifying the misconceptions and alternative conceptions of students in that certain topic. So we will be developing a representational task. We developed a representational task together with rubrics. This corresponding rubrics allows assessing further the understanding of the learners on the electron distribution of atoms. The primary objective of this study is to qualitatively and quantitatively assess the understanding of both pre-service teachers and in-service teachers, physical science teachers, in the concept of electron distribution of atoms. And of course, gather insights about understanding the response. So this is the research framework of our study. We developed the assessment tool and then created the parallel rubrics and then conducted it to 2 different groups, the pre-service teachers and in-service teachers. For pre-service teachers, we have 2 groups, chemistry and physics, since we're talking about physical science, and in-service teachers, representational task competences. And we paired this with the competence levels of representations. For methodologies, we developed the assessment task and the corresponding rubric, and then undergone expert and phase validity, and then it was administered to the 2 groups, the pre-service and in-service teachers, and then we identified the results. How did we identify the results? Since we developed a 5 representational task activities which are constructed and validated, we're also going to rate it using a 5-point Likert scale. We rated it using a 5-point Likert scale where 5 is the highest level of representation and 1 is the lowest level of representation to identify the understanding of the participants. So these are the results. So for the first group, the understanding of pre-service teachers, this is the summary. Okay, so we have 5 tasks. And depending on the 5 tasks, as you can see, and at the frequency and the percent distribution, the highest is the 3rd level, second is the level 2, and the lowest is level 3. That's their top 3. So the frequency of understanding of learners, of pre-service teachers, falls in level 1, level 2, and level 3. Now, comparing the physics group and chemistry group, physics students turn out to have more numbers of students to gain level 5 in representational tasks, but chemistry students also have more numbers of responses in difficult tasks, such as in task number 4. Both respondents from physical science department has exhibited an average result in the representational task. Now, there are two groups, the physics group and the chemistry group. The chemistry group, the physics group has the respondents from physics group, some of them are getting highest levels of representation. But for the chemistry group, although not all of them can go to that highest level of representation, they can, most of them are almost equally parallel of understanding. Hence, both groups showed an average understanding of the atom. For the in-service teachers, these are already the teachers who have been teaching, same activity and also same rubric is used to assess them. As you can see, the highest frequency falls in level 4 and level 5. Of course, that is expected because they are teachers. But why is there a certain level of percentage in level 1, 2, and 3? What could be the possibilities? It is observed that the teachers of in-service teachers have enough knowledge of the topic in the electron distribution of atoms since they have been teaching it. However, it was also observed that some of the teachers exhibited less knowledge of the concept. This could be implied from their personal profile that some of the in-service teachers who are respondents are not actually specialized in physical sciences like chemistry or physics. Some of them are biology, some of them are earth science specialists or geology. They are not actually chemistry or physics. So that actually influence their results. But in conclusion, among the takeaway of the teachers, the importance of representational tasks allow the students, and based on their responses, they can it can allow the students organize and reorganize their thoughts on the concepts and pictures out the idea, giving the importance in checking and correcting misconceptions, measuring their level of understanding, and reflecting on how to improve their understanding on the topic. Subsequently, the representational task makes the learners more detailed representation to demonstrate higher level of achievement. This type of assessment also makes students conscious of their thinking and learning process. And low achieving students tend to participate and misconceptions are corrected individually and mostly self-directed. Since the activity is very authentic, once they drew or illustrate their activity, you can identify already the misconception, and it can also be corrected. And the low performing students can actually participate since this is not calculation, this is not an essay, but it's a drawing. Now, those who are artistic students can actually participate. And for recommendation, a longitudinal design is further recommended to identify the stability of the obtained information over time. Therefore, the results should be treated as exploratory and not as conclusive given the limited scope of the study. So this could be springboard for the next research. So that would be all. I hope you understood understanding electron distribution of atoms using representational task. I would be willing to share the task with you. Thank you.